So now let's talk about using a real-time clock module. So now I really do want to switch over to the overhead view and first talk about wiring it up. So this module actually has the same pins. You've got your VCC, your ground, and then your VCC, and then we have a data and a clock, or yeah, a data and a clock line. So all I did was I just took that and I just piggybacked off of the OLED display and then tied it into here. And now the code does require a couple of libraries. So, and actually we don't use the NTP client anymore, so let me get rid of that. You need we need Adafruit Bus IO, and then we need the RTC library. Let me save that. And before I get too far,
back to your code.
Yeah, I'll jump back to the code here in just a second. I just want to make sure that, okay, we're on that project there. So,
okay.
Oh, here. Okay. So this one's pretty much similar. Okay, so the only two libraries we're using here is the real-time clock library from Adafruit and then their Bus IO library. And I had to include the Bus IO because for some reason it did not actually pull it down automatically. So the main, we're basically include SPI.h, and then the real-time clock library. And then there are actually different based on the chip that you have. So if you have a 1307, we've got that. But there's also see if I can, there's other ones here too. So time span. So that's the 1307 is the first one. And there's the 3231, which is the other popular real-time clock chip. And you notice this one doesn't have, this has really just begin, and you can adjust the time and then you can read it, right? Whereas this one, you can adjust, you can actually you can do now, you can actually set alarms and set alarm mode. So the 3231 has a little bit more more features to it. You can also, it has a built-in temperature sensor, so you can get the temperature off of that too. So if you needed to see what your temperature was of your board, you could actually pull that off because it's built into the clock chip. Here's another one that's the PCF8523. So that what they've done is they've basically created this library that talks to all the popular different chip types. So what we do is we start out by declaring the chip type, that we're going to be talking to, and then this days a week is actually being used by another function. So matter of fact, let's go see where its reference is. It's basically being used down here when we print out the day of the week. So let's get back up here to the top. So our setup, and here what we're going to do is we're going to just set serial begin, and then we'll initiate the real-time clock. If it fails, then we're going to go into our never-ending loop saying we can't find the real-time clock module. And then this actually initially populates the real-time clock, and you only need to do this once, because once you set that, as long as you don't pull the battery out of it, it will remember that date and time and maintain it. So, but what this does is this actually takes the current date and time that we compiled the program and uploads that to the real-time clock. Now we could also go back and use the network time, or the network, the NTP client, and get the current date and time and adjust it to that every time we boot it up. You can also manually set it to a date and a time if you wanted to. And then this, in the loop, it just basically calls, give me the current date and time right now. And then it just breaks it out. And so this date time object, if we go look at that, it basically has the year, the month, the day, the hour. If it's if you want a 12-hour clock, then it brings you back to 12-hour. If you're using 12-hour, then you can use is PM or AM, the minute, the seconds, and then the day of the week. And then this is the number, and then the seconds in time since 2001, and then you've got your Unix time, which is considered the epoch time, since January 1st, 1970. So that's everything that comes back when you call UTC time or .now. And then basically what it's doing is it's just going through and printing out each one of the date and the time. So let's go ahead and let's kick that off. And once he starts popping up here, all right. It's uploading. And we'll switch over to the serial monitor. And now see, this is showing local time instead of Zulu time. So if you wanted Zulu time, you'd have to offset your Zulu in that. So what we'd want to do is we'd have to subtract the hour minus that, but you'd also have to minus the day and everything. Or we can go back over here. Let's go look at this, the definition for this guy again. And let's see if there's a, it doesn't look like there is a, is running now, read. Nope, it doesn't look like there's a time offset for the library.
Now this one's a lot closer than the other one, time wise.
I say it's 15 seconds slow.
I'm showing about 6 seconds slow.
How many devices are you looking at? I'm looking at three different devices here, and they're all within 1 second of each other.
I'm just looking at one device.
Yeah, Jim, a lot of times they have different levels of pools. And so it may be sending you to one of the lower ones, which can be off. So you could probably even try like a Microsoft NTP server or something.
Yeah, two of my devices are internet conditioned, and they're right on, and then my cell device is cell tower conditioned, and it's 1 second. Let's see, 1 second behind the internet. So internet seems to be leading all of them.
You can always try time.windows.com or something. Oh, that's the DNS name for the NTP server for Microsoft. See, time.windows.com.
Yeah, time.gov coordinates exactly with time.is. So those two are dead spot on. The cell tower is 1 second off.
Surprising the cell tower is off because that's supposed to sync. That's supposed to be,
Yeah, I thought that would be the most accurate, but
that should be the most accurate.
time.gov is dead spot on with time.is, and the cell tower is 1 second behind actually. So I don't know if there should be that much delay.
Jim's time is like 5 minutes off though, right?
I know, yeah, that one's
Yeah.
really off. So not sure. It was only a little bit earlier, but it's weird. Did we lose Jim's audio, or is he just concentrating?
Jim, you hearing us?
Yeah, I'm here. Can you hear me now?
Yeah.
Yes.
I think this mic lapel mic is dying on me. Now let's see what we have now, because this is okay. So we're 150.05, right? So let me switch back over here, 150.11. So let's so we're right on time with it now. That's using the NTP client, correct?
Yes.
So what we can do is we could take that same code and we can use that to adjust our real-time clock. So let's do that as a final exercise. So what I'm going to do is we're going to need,
when you're adjusting it, you're not adjusting it to us there's so many sources out there. You're just picking one, and it's not in the hierarchy, is it?
by default.
I mean, most of these
And
should be synced to the national observatory time.
Well, that's what time.gov is an NIST,
Is it?
official U.S. time. Yeah.
okay, so what I'm doing right now is I'm adding the NTP client to our DS1307 real-time clock. So let me add that in. That's going to update our library. So now we have that in here. So now what I'm going to do is I'm going to go steal some code. This is where I always screw things up. So I'm going to need to grab, we need all these guys here.
Time hack.
Oh man, I lost all of that. Hold on. And then I'm going to just grab this. Can you guys hear me now?
Yeah.
Okay. My other mic was basically ran out of juice. So now we should be able to get over here and compare this. He connects. We've got 655, which is our GMT offset is wrong. So we don't need this anymore. So let's get rid of that. And get rid of that line. And then let's redeploy it. And then we'll look at how it compares with time.gov here in a second. Okay, go back to the serial monitor. Okay, we have 156. Got 156 there. So let me set this. I just want that. So we're showing 157.03, 05. So we're pretty much within a second. So that's, now we know it's set. Now I should be able to now that we've adjusted the real-time clock, right? I should be able to take this guy and comment it out. I'm going to try this again. And I'm going to recompile it and upload it, because you should only have to do that once you set your real-time clock. And I should get, it should keep time. Okay, 58, 58. So now let's shrink this and let's see, 14, 15, still in sync. And that's after a reset. So I should be able to do a power reset now. So I disconnect it and we'll delete this guy. And I'll plug him back in. And once it comes up, you should be able to connect to the serial monitor. And 48, 40, 51, 52, we're still within a second. So that's the whole reason behind having a real-time clock module, is once you get it set, no matter how many power off, power on, it should stay, as long as your backup battery is good, just like in your laptop, it should maintain your time. And because we're not setting it, you know, if we wanted to set it again, we would just basically create a function that would go out and do this again. We could use a button to have it sync it.